Hello, I'm implementing new functionality in Sparrow, which is supposed to improve data extraction. And the idea is to use OCR, which comes from PaddleOCR, and use this information to enhance the output produced by Vision LLM by supplying to Vision LLM not only the original image and the query, but also to supply the text coming from PaddleOCR plus coordinate system, but this information is not taken just directly from PaddleOCR. OCR is being processed by Sparrow, and then it's being sent to Vision LLM, so with some additional custom functionality. And today I'll show some early tests, and I'll demonstrate actual example where I show how this approach improves the output from Vision LLM. So this is the goal of this video. Right, let's go to actual example. Let's try to go to full screen, and this screen comes from Mac Mini machine where actual Vision LLM inference runs. This is Mac Mini 64 gigabytes machine, which is able to run quite large models. Okay, this is the example of receipt, and the idea is that I'll pass this receipt to Vision LLM, like the one I'm using for this example, Mistral, and we'll see that Vision LLM will not be able to process this kind of receipt. There'll be errors related to commas, so the price information will not be fetched correctly. So I'm using Mistral Small, 8-bit model with 24 billion parameters. Then in this case, I'm using original query. I'm saying that I want to retrieve document data and return response in JSON format. And I'm passing the image and I'm passing the query here, and all the heavy lifting is being executed through Sparrow parse library on local Mac Mini with MLX and MLX VLM. Okay, so let's run this, and then it will execute. We can switch to Mac top, and we'll see that GPU is running and memory is loaded, which is fine. And in few moments we should get the result. And currently it runs in debug mode, so it Sparrow parse displays the model used for this inference. As I said, it's Mistral Small. File path is printed, and the query, let's say, is that retrieve document data and return response in JSON format. Right. Okay, so we got the reply, and it was 45 seconds. It's quite good running locally. And then let's compare output with the one from original document. So we got the name, Bintang Bremer, correct, quantity 1, and here's the mistake, price. Vision LLM reports as 59,000, but original value is 59, and 30. So not sure the currency, but I guess it's like $59 or something, and 0 cents, or maybe, yeah. Again, maybe it's correct. Maybe it says the comma. It just the way to show that this is 59,000, right? But maybe not. And the thing is that from Vision LLM we were not able to get comma in this case, and maybe it's important, maybe it's not important. Depends. But we are losing this information over here. And now I executed the same receipt through OCR, and from PaddleOCR I was able to get the price values exactly as they are, with comma, with proper formatting. So it's 59,00 and 10,00 and so on. And now the idea is that I'll go again over here and I'll include now additional logic where prompt will be constructed using OCR data, and this prompt will be sent to Vision LLM. And in the prompt will indicate that please use as a priority data from OCR, and Vision LLM task will be only to map key value pairs correctly and prefer actual data that is coming in the input, which originally was coming from OCR. Okay, so we included the prompt, and then instead of using original query, we'll use query from the enhanced prompt. Okay, so now let's execute again. Okay, we can see that now the prompt is different. So we have now some additional information saying that we're analyzing document data, and please use as a primary data from OCR, and we're passing OCR data and converted spatial information with box coordinates into positions, so that every text block which was detected in OCR is assigned position. And I noticed that this helps Vision LLM to process data more effectively, and it's easier than for Vision LLM to identify key value pair relationships and build structured output based on this information. So it's not only raw text information we're using from OCR, but we are also using spatial information. Okay, and then additionally we say that we pass critical instructions that enforce Vision LLM to prefer data coming through the input, this original data from OCR. Okay, we got the result, 49 seconds in this case, and now key value pair mapping is correct. And if we refer back to original document, we can see that price information is also formatted well in this case. So we have 59,3 zeros, which probably indicate that's 59,000, but if correct formatting now. And my point is that in this case, probably it's just a formatting issue, but it could be we could have a situation where the price would be like 59.70, and Vision LLM could hallucinate and produce the output 5,970, which would be completely wrong if you would miss the dot, right? And in this case, when we use OCR data, and it's a higher chance, it looks like it's higher chance to get correct data when we run it through OCR, and then we feed this data to Vision LLM just for them to identify structure and relationships between data. So it seems like it's higher chance to avoid hallucinations coming from Vision LLM in this case. And for the second row, we got chicken HH1, and it's 190, correct. This row is also correct, and then total 259 is correct. Service, tax, discount 19, and total 302,016 is also correct with comma. Okay, so this was my point, and this is the original JSON data coming from PaddleOCR out of the box. Then this data is being processed in Sparrow, converted into the query prompt, which then is sent to Vision LLM along with the original image and the query to be processed and to get back structured output from Vision LLM. So thanks for watching, and see you next time. Bye.